Here's a little glimpse of a circuit I'm working on. It's got a Schmidt trigger right here that the rotor dial is hooking into, and the rotor dial is debounced. Goes through a Schmidt trigger. It goes through a decade counter, and then that decade counter is powering that 7-segment LED driver chip. We also have LEDs over here that counts the binary output, the BCD output of the counter, as well as a 7-segment LED just for funsies. Now the counter comes in over in here into some multiplier chips, and these chips perform a 4-bit by 4-bit multiplication. So whatever number is dialed on the rotary dial is the left-hand side of the equation, and the right-hand side is controlled by the dip switch here. Currently I have it set to 1, so 1 times whatever number is always going to be the same number. That output goes to 2 7-segment LED drivers down in here, although that only works for numbers under 9, unfortunately, because the math chips here produce binary output, not BCD output. That's okay. This part isn't actually part of my final solution here. And then the output of the math chips is binary, 8-bit binary, and that's going through to 2 decade counters set up in binary mode, right? So those are also 4029 CD4029 chips, but they're set up to count binary instead of BCD. They are also set in countdown format, and the switch right over here will decrement the count on the clock and count down. And then the LEDs down here represent the binary output. So if we dial a digit on here, we see that we dial the 1. 1 times 1 is 1. And then you saw the number 1 come up on the LEDs. One thing I didn't mention is I thought it'd be kind of cool if the circuit, act like it was thinking. It had a little bit of a delay. So there's a 555 timer down here that is set to wait for around 2 seconds and then generate a pulse through a PNP transistor. And then that pulse is what sets the reset on the 2 counters down here, which was actually the pre-enable, right? And that loads the data onto the LEDs here. So any number we dial is going to show up there. I'll dial a 5. Yep. Let's dial a 9. And there we go. Now it gets more fun when we want to multiply by something. Let's go multiply by 2. And we'll dial 1. 1 times 2 is 2. There we go. 2 times 2 is 4. There we go. Let's go 5 times 2 is 10. So this isn't going to work because it's binary, but this shows us 8 plus 2 is 10. So that's pretty cool. Let's go all the way up to 9. Pull the dip switch out here. So we'll do 8 and 1. That should give us 9. As long as I got the switches set right. Dial a 1 to confirm. Yeah, so 1 times 9 is 9. And we get a 9 on the output. 2 times 9 is 18. Of course, this isn't going to work, but this will. Yeah, and we get a 16 plus 2 is 18. So, 9 times 9, 81. So once again, this isn't going to work because binary, but this does show us, I think this would be 64 plus 24 plus 1 would give us 81. Yeah, pretty neat.